I think one of the also important things to realize when you designed a plant for remote operations is that you would have lots of integration between different disciplines in the plant. So all the different types of equipment that you would normally have as separate disciplines before, and they would design one piece of electrical switchgear there, you would design a piece of automation DCS system there and a safety system there. Those things now have in the recent years, and I would say specifically over the last 10 years, they are interacting much more with each other now than it did in the past. So we have all this electronic change of data, which gives you the ability to fetch a lot more, let's say, condition-based data out of every piece of equipment that you have on a plant. So this really gives you a challenge to design a system that is able to retrieve all of this data in a secure way and aggregate them into a system where you can make use of them and make sense of them. So that's what we are looking at when you design a system. And obviously, I think when you design a greenfield plant, it's a lot easier to do this than when you actually go on a brownfield plant and try to replace or modify that plant to be a remote operated plant. But I'd say that same as the last slide, the technology is already there, so it's really about the thought process and the mental change that we have to go through in the industry. Here is just a quick example and some savings that you can see, which is very typical for remote operations. We say and a lot of studies say that planned maintenance is some 30 to 40% more cost efficient than unplanned maintenance. So if you can move your maintenance from unplanned to planned, you have a huge saving. And some people say that it's even more than 30–40%, but I use that as a conservative example. And then, if you then go from planned to condition-based, you even then have I would say 8 to 10% more. So really, one of the purposes is to take you from unplanned to planned to condition-based to get those savings out. And down here you see an example where you really have a sensor, you have a signal processor, you need some form of condition monitoring, and then you have some diagnosis, and then you make a prognosis of what's going to really happen to this equipment over the next days or weeks or years, and see how it will behave, and then you take your decision based on that. Will the piece of equipment be alive for another week, or will it be alive for another day? Do I have to do something now, or do I have to plan for something that is 2–3 weeks ahead or 2–3 months ahead? So that's really where you want to go. You want to take it from unplanned to condition-based. So if I take an example, and this is a study from DNV in the North Sea, where you see that unplanned maintenance, which is the 19% that you see here, this is the actual figure today. So in the North Sea, they have 19% unplanned maintenance, and they have 17% planned. So a bit more than 50% unplanned, actually, these days. So if you look at the savings potential of a plant that has a couple of $100 million in OPEX a year, which is, I would say, an average-sized oil plant would be a typical this number, then you see that if you move yourself from these a bit about 50% unplanned, and if you this bit less than 50% planned, if you move that up to 75% planned, you would get huge savings. You would get $5 million a year here, and if you move further on to 50% of that being condition-based, you would say another couple of millions. So if you have a 20 years life cycle of a plant, you get $140 million in saving. And I'd say for most of us that sits around this room, we would know that $140 million would be a real nice automation system, right? So, so this is really what it's about. It's about designing the system so you get those savings out. This is where Shell is at this point in time. They designed the plant with the purpose of having 70% condition-based maintenance. And actually at this point in time, they are at 55% condition-based. So they are a bit above the rating I gave in the examples on the condition-based, and they are a bit below when it comes to how that it's planned maintenance. But they have some real good savings ahead of them. We have, to facilitate this, implemented some 2,000 asset monitors. And those asset monitors are out there in the field. They are monitoring mechanical equipment, rotating devices, instruments, automation systems, all types of telecom systems, all types of equipment that we have installed. And we have, as a part of the service agreement, a number of hours every week to do a health check on the plant. So that's part of the service infrastructure that we have with Shell, that the health check and the health care of the system we take care of remotely and make sure that we monitor that and that we give feedback to Shell if we see some things that are not as they should be. The next topic is process tuning and remote process tuning. And these curves that you see here is really, this is the startup curve of the gas plant. And here really the objective is two things, is to provide better stability, making sure that you don't have any shutdowns, because a shutdown will cost you some $10 million. And then, of course, making sure that you have better throughput so that the process is tuned in order to best make the most out of the mechanical equipment and the tanks and the separators and yeah, what you now have on these plants. So really the quality of the process is regulated also remotely. And we have now started to do most of this, as you see here, was done at site, because that's really not comfortable for the oil companies to do a lot of that remotely, especially if you go into critical processes. But we have started to do some non-critical process tuning from remote these days, which is really giving an example of and see how it works with the interaction with the control room and these kinds of things. So it's quite interesting. So summary, what you want is to take out this green area. You want to take the value of your plant up, so really the production you want to take up to the purple bar here, and you want to reduce the OPEX from the blue down to the yellow, and you take out this green field here. Then the armor room. We have two armor rooms. We have one over in Bergen, which is a bit closer to the plant, but still quite remote, and we have one over in Oslo. But really what is important is not, I mean, Oslo is some 500 kilometers. How much is that in miles? 500 kilometers from the plant. Really, it doesn't matter whether it's 10 miles or 50 miles or 100 miles or 1,000 miles. Really what it comes down to is the utilization. And as you see, we have 2,000 logins from the armor room into the plant per year. So that means you have some 6 times per day in average, roughly, right? So 6 times per day is our expertise staff logging onto the plant to solve some problem or having some interaction with the control room and the process. It's quite amazing how it picks up. And you can just think about how much that saves in air traffic, in logistics, in time, in travel time, in being exposed to HCC events, these kinds of things, making sure that you stay away from problems. So I think this is really nice to see that you have big utilization of the armor room. Show you a quick film, what will happen when you utilize the armor room.
ABB introduces a more secure future. As a reliable partner, we help your company comply with all necessary industry standards and ever-increasing regulatory requirements. At the same time, we keep your systems safe. IT is being used by most companies for monitoring their process automation systems. ABB's remote monitoring and operations services guarantees the secure operation of these systems so our customers can concentrate on their core business. ABB's services now include incident management, maintenance of a site inventory database, system setup and maintenance, as well as remote condition monitoring for ABB and third-party equipment. Through this service, ABB facilitates a high-level infrastructure. This gives our customers remote access to on-site automation systems, including interactive access via terminal services. The service includes a multi-tenant desk application suite, offering all the functionality required for the management of service requests and other incidents. ABB has specially secured onshore operator rooms called Armor in multiple locations. Remote work on hot installations can only be performed from within these rooms. Only authorized personnel has access to Armor rooms for remote connection. The authorization process is secured by ABB's procedures and is approved by the customer. Using ABB's remote monitoring and operation services lets you focus on what you know best. Leave it to ABB to secure your future.
Okay, so some prerequisites of how we want to deal with the integrated operation and specifically remotely. IT security is absolutely essential, I would say. Absolutely essential that you have really secure network and that you design your IT network so that you can pick up data and send data without having any issues with security at all. Remote rooms, and then we talk about work processes. And then I would say service level agreement we talked about, and then asset management packages. Then I would say if you have the ability to have a simulator, so that actually that you can test your changes before you actually implement them on site, specifically if you're doing remote changes, then it's a real big benefit. So some lessons learned, organizational challenges and work processes, that's really key. So we need to take that into account. And I think, I don't know if this applies for all industries, but at least for oil and gas industries, I would say, as of now, the integrity of the plant has to stay in the control room. You cannot let that out of the control room. So the plant is really where the decision has to be taken. You cannot be outside the plant and take a lot of decisions, specifically when it comes to process. So I think this philosophy is essential. Then I think oil companies and other industries as well have to realize that, I mean, you have to build some expertise in your own organization, but if you want to take advantage of this, you have to leave some of the expertise outside with the supplier industry as well. Then some may find it a bit awkward or not comfortable to have a very close relationship with your vendors. I think that's a change that these remote monitoring facilities will give. It's a change in the relationships between the vendors and customers, so you have to have a much tighter cooperation than you had before. And then I think try to simplify the structure in terms of how you integrate different types of equipment. Try to make sure that you get this electronic exchange of data so that you actually can retrieve it via one system and not have hundreds of different systems on the plant that picks up this data and this monitoring data. So, and obviously there's a lot of dollars to catch here, in my opinion. I think we have only seen the beginning of it. So, thanks.